All right, so a little light review on Quiz 1 content. So first I'm saying find the missing sides in each triangle below. Simplify all radicals, box all answers. So in the first one, I just have a right triangle. And the first thing that I look for, is it a common triple? So let's say that I reduced each of these sides down. Divide by 2, I would have a 4, 5 here. I don't have any triple that has legs with 4 and 5, so I do not have a common triple here. So I'm just using Pythagorean Theorem to solve for the hypotenuse. So I know that 8 squared plus 10 squared equals x squared. So then I have 64 plus 100 equals x squared. So x squared equals 164. Take the square root of each side. So 164 is 4 times 41. So I end up with plus or minus 2 root 41. But I can't have a negative measure for a side. So that hypotenuse has to be the positive. It has to be positive 2 root 41. So I had to just go back to the basics, use a little Pythagorean theorem. Okay, for the next one here, I'm giving you a 45, 45, 90, or an isosceles right triangle. So the two legs are x, and the hypotenuse is x root 2. So then my other leg here has to be 5 root 3. And then I'm multiplying that 5 root 3 by root 2 to get 5 root 6. So my missing hypotenuse ends up being 5 root 6. Okay, then I have a 30, 60, 90. So my short leg is x, my long leg is x root 3, and my hypotenuse is 2x. So I'm starting you off with the long leg, that's the x root 3. So what I'm really doing here is I need to divide away that square root of 3 and then rationalize. So what I'm doing in terms of the mechanics of the skill is I'm going to take a third of the 24 and then multiply by root 3. So I know right away that this side will be 8 root 3. Let me remind you of those mechanics. So again, x root 3 equals 24. Divide away the square root of 3. Rationalize the denominator by multiplying by the square root of 3 over itself, right? That's just 1. I can multiply any ratio by 1, right? And I'm still preserving the original ratio, just looking at it in an equivalent structure. So now on top, I have 24 root 3 divided by 3, right, which is where that comes from, where I'm taking a third and multiplying by root 3. I get the 8 root 3. I'm just confirming right there that that's what I get. And then I double to get to the hypotenuse, so I get 16 root 3 right up here. All right, next up, just a little review from last semester, right? We reviewed this at the start of this semester too. So what range of values can a triangle with the following sides have for its third side? So I know that that third side has to be bigger than the difference and less than the sum of the two known sides. So that third side, if I call it C, has to be greater than the difference, but less than the sum of the two known sides. So then I know that C has to be greater than 19 minus 10, so 9, and less than 19 plus 10, which is 29. So I could leave it in inequality form or interval form. Either one is fine. And then to help you visualize those two extremes, so picture my long side of 19 and that short side of 10. Let me try to draw them to make them as close together as possible. This angle right here is close to 0 as possible. So then that third side, you can see that third side right there what we're calling C in this example, has to be more than 9 or it would be a straight pathway. And then if I draw the other extreme, right, here's the little 10 and here's the 19, right there, I'm making that angle as obtuse as possible without being 180. And if I connect here, I can see that that third side has to be less than 29 or I'd have a straight pathway again. All right, next for 3 are the following possible side lengths of a triangle. State possible or not possible. So we're really taking this part of the triangle inequality theorem. We're saying, is that third side, the biggest side, is it less than the sum of the 2 other sides? So 20 is my biggest side, so that's my C. Is 20 less than 8 plus 12? Well, no, it's not less than itself. That's silly. 20 is not less than 20. That's a false statement, which means it is not possible. And again, I always like you to be able to visualize it so you're not just memorizing rules. If I show you the 20 and then I draw the other 2 sides, I can see that straight pathway. All right, next skill, 3 sides of a triangle are given. Classify as acute, right, obtuse, equilateral, isosceles, or scalene. So looking at these 3 sides, I don't right away know which one is the biggest. So I'm going to first just write the structure that I need to follow. So I know that this is a Pythagorean inequality. So I'm looking at how C squared, the biggest side squared, relates to A squared plus B squared. All right, so I'm just going to go ahead and I'm going to square the 3 root 2, and I'm going to square the 5 to see what's the biggest number, and that would go in this slot right here. So 3 root 2 squared is like saying 3 times 3 times 2, 18, and 5 squared is 25. All right, so that's telling me then that 5 is my biggest side. So 5 squared is 25. How does that relate to 18 plus 18? So 25 is definitely less than 36. So that tells me that it's an acute triangle. If I see a less than sign here, it's acute. Equal to is right, greater than is obtuse. So this is acute. And since I have 2 sides that are the same, it is also isosceles. Isosceles triangles have 2 or more sides that are congruent. All right, next skill. A right triangle has the following side measures, 5 and 7. Find all possible measures for the third side. Okay, so we're told right off the bat that it's a right triangle. So it could be that the 5 and the 7 are the 2 legs, and then I'm solving for the hypotenuse right here. Let me mark that. Okay, or it could be like this instead. So it could be that I'm given a hypotenuse, which means that that's the largest side. It would have to be the 7, and then 5 would be a leg, and then I'm solving for the other leg. So then it's just a bunch of Pythagorean theorem to find those 2 possible sides. So here, since this is the hypotenuse, I could take the shortcut and say it's the square root of 5 squared plus 7 squared. So 25 plus 49 gets me 74. 74 would be 2 and 37, so there's no pair in that. That's going to help me simplify. So I leave it at just root 37. Okay, I could have just written it out full Pythagorean theorem. I'm just showing you the shortcut. So here, if I'm trying to solve for a missing leg, right, I know that a squared plus b squared equals c squared. Ultimately, it's going to be that 7 squared minus 5 squared, and then reduce what's left over. So 7 squared minus 5 squared. Hypotenuse squared minus a leg squared. And then take the square root, and we're looking at the other leg. So here I'm going to see 49 minus 25, which will be 24. So square root of 24, that is 4 times 6. So 2 root 6 would be this missing side here. So the third side could be 74, root 74 if it was the hypotenuse, or 2 root 6 if it was the leg. All right, next skill, solve for x and then find the area of the right triangle. So here I see some variables. I see x here, 4x here, and then I see a radical for the hypotenuse. So I need to solve for x, so I'm going to use Pythagorean Theorem first. I know that x squared plus 4x as a quantity squared equals 3 root 17 squared. So here, the biggest mistake that I see usually happens here, right? I'm squaring 4x, the package of 4x. So I'm squaring the 4 and I'm squaring the x. So in my next stage, I have x squared plus 16x squared equals, well, here I'm really doing 3 times 3 times 17. Let me just write that out. And that ends up being 153. I have like terms here, right? They're both quadratic, so I can combine and make 17x squared equal to 153. Divide that 17 away. X squared equals 9. And then take the square root, right? I would get plus or minus 3. And again, it's going to represent a side that has to be positive. So I'm only interested in the 3. Okay, so if I plug that back in, here I have 3. 4 times 3 is 12. So area for a triangle is half the base times the height, and my legs are the base and the height. So I'm looking at the 12 and the 3. So half of 12 is 6, times 3 is 18. So I have 18 square units. All right, problem 7. Here I have 2 special right triangles that share a common side. So they have the common side right here. So that will be the same for both of the triangles. A good strategy that I always think is just to split them up and view them as 2 separate entities. So I'm going to draw the 45, 45, 90 over here. Label this as 24. And then over here, the 30, 60, 90. Label my 30 and my 60 and the C. Okay, I'm going to remind you that we have that common side, that shared side right there. So now, on the left, I have a 45, 45, 90. So I have x, x, and x root 2. So now my x root 2 side is 24. So my shortcut is to take half and multiply by root 2. So I'm going to get 12 root 2 here and here. Okay, let me remind you longhand how that works. Right, x root 2 equals 24. I'm going to divide away the square root of 2, and then I'm going to rationalize. So I'm going to multiply by root 2 over root 2. That gets me 24 root 2 divided by 2. Right, so again, in the mechanics, I can see how dividing by 2 is the same as taking a half and multiplying by root 2, right? It's confirming that 12 root 2. Okay, so now again, where this green is, that's my shared side. That's the common side. So this part right here has to be 12 root 2 also. And in my second triangle, it's a 30, 60, 90. So my short leg is x, my long leg is x root 3, and my hypotenuse, right, that's my 2x. So building there, half of 12 root 2 is 6 root 2. So my short leg is 6 root 2. And then I'm taking that 6 root 2 and multiplying by root 3, and I finish up with 6 root 6. Okay, last skill is just a review of those regular polygons. So I gave you one of each, and I'm saying that they're all regular, so we know that that means that all of the angles are the same, and so are all of the sides. So angles congruent and sides congruent as well. We have different entry points for all these problems. Sometimes I give you a side or a perimeter or the apothem or the radius, and you just have to know how to connect the dots to get to the end result. All of these regular polygons, they have a special right triangle inside of them. So it could be a 45, 45, 90 or a 30, 60, 90. We will be able to extend this to other regular polygons like a regular decagon or regular octagon. Once we learn a little bit more, we have to learn trigonometry first. So right now we focus on the ones that have that special right triangle inside. So for the first one, an equilateral triangle, I'm going to draw in a radius. I'm given the apothem. I know that all of these angles are 60. So if I bisect this one, I have a 30 here and a 60 here. So opposite the 30 is x. Opposite the 60 is x root 3. And opposite the 90 is 2x. So I'm going to use that 1/2 apothem times perimeter formula. Right? All that's doing is it's visualizing how this triangle can split into 3 congruent isosceles triangles, where this part right here is the apothem, and their collective bases is the perimeter, right? So that's really what I'm visualizing. So I need to get to my perimeter. So if I know, let me just write that formula first. Area is 1/2 the apothem times the perimeter. So if I know the apothem is 9, then I know that right here is 9 root 3. But that's half of a side. That is half of a side right there. So if I want a full side, I double it to get 18 root 3. And then my perimeter, right, I'm just taking that 18 root 3 and tripling it because I have 3 sides that are all the same. So I get 54 root 3 for my overall perimeter. So I'm just going to multiply across 1/2 of 9 times 54 root 3. So I'd probably take half of the 54 first, that's 27, and then multiply by 9, and I would get 243 root 3. Units are squared, always the case for any area problem. All right, for B, for the square, I'm giving you the apothem. So the apothem, what's nice for the square is that I can just draw in the other one and get the same, 9. So that means that all of my sides are really just 18. And with the square, I have a lot of options, right? For a square, I could do base times height, or a side squared, or 1/2 AP, or 1/2 diagonal 1 times diagonal 2. They both work, or not even both. There's more options. There's like 4 options that work. So whatever you see clearly is fine. I'll do base times height because I know they're both 18. So area would be base times height. 18 times 18 would get me 324. Units are squared. All right, and then lastly, here we're looking at the regular hexagon. So I'm going to draw in my radius right there. Okay, I'm going to mark my angles. So again, here all of these angles are 120 to start. So if I bisect this one, I have a 60 here and a 30 here. Opposite the 30 is x, opposite the 60 is x root 3, and opposite the 90 is 2x. So I'm going to have to use 1/2 the apothem times the perimeter here. I'm visualizing that same strip of triangles, except now I would have 6 of them because I have a 6-sided shape. All right, so now if I build off that x root 3, I'm going to take the shortcut. So here, if I'm going from my x root 3 side to x, I'm going to take 1/3 of it and times root 3. So I have 3 root 3 for this short leg right there. Okay, that's really 1/2 of a side. So a full side would be 6 root 3. Okay, it would be the same as the radius for this shape only. So a side and a radius are the same when it's a regular hexagon. So if I need my full perimeter, I'm taking that side of 6 root 3, and I have 6 of them. I have 6 sides that are all the same. So if I multiply by 6, then my perimeter is 36 root 3. So now plugging all of those items in, I'm taking 1/2 the apothem, which is 9, times the perimeter, which is 36 root 3. So if I multiply across, I'll probably take 1/2 of 36 first because it's even. That's 18. And 18 times 9 is 162 root 3. So 162 root 3 units are squared. All right, so nice, short and sweet review for quiz 1. Have a good day.